Jai Hind everyone. So this is Dr. Avdhesh Gupta, and today we will discuss a new algorithm in cryptography, Diffie-Hellman algorithm. Okay, this is basically a very important algorithm for computer network subject as well as for cryptographic subject also. So what is Diffie-Hellman algorithm and how it is introduced and where it can be used? Just because we are using different types of encryption, decryption or cryptographic algorithm like RSA, like DES, like triple DES, AES, then what is the use of Diffie-Hellman? And whether we are using Diffie-Hellman algorithm currently? Yes or no? Maybe yes. So Diffie-Hellman algorithm is important, but not important as much RSA algorithm, because RSA algorithm is a good algorithm. And currently we are maximum times of seeing that RSA algorithm is in use. We are not saying that Diffie-Hellman algorithm is not used yet. Diffie-Hellman algorithm is also used, okay, because this is the first published public key algorithm before RSA. The purpose of this Diffie-Hellman algorithm is to exchange a secret key between two parties. Diffie-Hellman algorithm is a alternate option of RSA, or you can say RSA is the alternate option of Diffie-Hellman, where the different types of keys are available. The sender uses the private key and the receiver uses different, it can decrypt it by using different keys. So there is a public key and private key. So two keys are available, one key for encryption, another key for decryption. And this algorithm depends for its effectivity on the difficulty of the computing discrete logarithms, because it has some limitations also. It uses to exchange the secret key, but it has some options also. That's why this algorithm is not using widely currently. Okay. So what is the Diffie-Hellman idea? If we say that there are two parties and we have to see how the algorithm works, how the keys are exchanged between these two parties. Alice and Bob, these two parties want to communicate with each other. Okay, 1/3 of the key is public. 1/3 key of the key is public. So Alice fill up another 1/3 of the secret key using her random number. And Bob fills up another 1/3 of the secret key using his random number. Okay, so G is already available, X is decided by the Alice and Y is decided by the Bob. So now what it needs to do? They are not exchanging X and Y, but this Y to be shared with this one and this X needs to be shared with this one. So Alice completes the key by adding the last part, this X and this Y. So both have X, Y and G, and this also X, Y, Y, X and G. So these two keys are the same because it do not matter if X filled first or Y filled first. So both are the same. So the question is, how can we transmit the keys? If I am transmitting the X or Y through a network, the hacker can easily read what is the value of X and what is the value of Y. So we need to encrypt X or Y also, but on what matter, what case? Let's see. Let's suppose Alice choose a random number 6. Meanwhile, the parallelly Bob choose a random number 5. It means there can be a two random number, anything. Listen, these are the secret random number. Any random number we can choose, but Bob and Alice have the following: 23 and 11. Bob, a number generated by the Bob which is 23, and Bob generated a number 11 which is 11, generated number 11. So this is the Bob's number and this is the this is the Alice Bob number, this is the Alice number, and both need this one. So another random number is 6 and 5. Now Alice compute G to the power A mod P. So what is the value of G to the power A? This 11 generated by the Alice. So what Alice did, 11 to the power 6 by this secret number and mod 23 by this. Okay, so after calculating this, it can find the 9. Ab 9 is a number, a new number again, by using these two keys, and a secret random number chosen by the Alice is 6. So this is a formula to encrypt my secret number by using this formula. Similarly, Bob also compute B is equal to G to the power B mod P. So what it do? G is 11. This is also G. G is 11. So 11 to the power 5. 5 is the number generated by the Bob. So 11 to the power 5 mod 23. 23 is a prime number which is known to all. 23. So the number is 5. 5 is a number which is a encrypted number or generated by using some special formula. Then this number and this number has been exchanged between these two parties, not the actual number. So the 5, this 5 has been received by the Alice, and this 9 has been received by the Bob. So Bob receives 9 while Alice receives 5. Now the secret key. Secret key is equals to B to the power A mod P again. There is another formula. This is a secret key by which we can use encryption. So this is 5 to the power 6, 5, the number which is generated by this 5 to the power 6, 6 from where? 6 is here, 6 mod 23, 23 is what? This is 23, and it again generate a new number 8, and what it do? K is equal to 9 to the power 5, 9 is generated by the Alice to the power 5, 5 is this, and mod 23 is also 8. The common secret key is 8 now. This is the common secret key. Also, we can see that there is another thing, this we can also written this K is equal to G to the power AB mod also, mod P. Okay, so this is another formula we can use the K also. So the common secret key is 8 is the common secret key among or between these two parties. So this is very important. So this can be done if you know everything, but the formula is this, and then again secret key and the secret key. This is how the secret key can be exchanged. Now another example is this. The P prime number is 13, another is G generator of P is 6. Now the private key is 5 and the private key is 4, randomly generated this primary key. Now again the formula is applied, 6 to the power 5 mod 13, 6 to the 4 mod 13, and using another thing 7776 mod 13, and public key is 2, and similarly mod 13 public key is 9. So these are the public keys 2 and 9. Exchange these two public key, and by you applying this formula 9 to the power 5 mod 13 is secret key is 3, and 2 to the power 4 mod 13 is secret key 3. The 3 is common. This is exchanging public key, and these are the keys. So this is the shared key, can be generated as a shared key to the power private key mod P. So this particular 3 can be calculated by using this formula also. So this is the algorithm. If you want to write the algorithm in this way, you can write the algorithm in this way in graphical representation, or if you want to the algorithm in this way, you can write in this way also. Like for example, there are two public known number, a prime number q and an integer a, that is alpha, a primitive root of q. And suppose user A and B wish to want to exchange a key, then user A select the random integer xa which is less than q and compute y to the power y is equal to x to the a to the power xa mod q, and B also independently select another random number and compute yb is equal to a to the power xp mod q, and each side keep the value private available to public to the other side, exchanging, and user A compute in this way and B compute in this way. Okay, so you can read the statements from this slide and you can perform the operation using this particular algorithm. And basically this algorithm can be understood in a very good way by using this graphical representation. So now we will study some examples. Let's say this the prime number q is equal to 353 and primitive of root is q is 353. In this case, a is equal to 3. A and b secret key is 97 and xb is equal to 233 respectively. Each compute its public key as in this way. So a compute public key is 40 and b compute its public key 248. And these two values are exchanged between these two parties. After exchanging, they are able to generate their keys. And if they generate their keys, the common key can be generated by using these 160 and 160 generated by A and generated by B. And we assume an attacker have available option Q is equal to 353, A is equal to 3 and YA is equal to 40 and YB is equal to 248. We may assume. Then in this simple example, it would be possible to determine the secret key by brute force algorithm. So this is the drawback of this algorithm. The brute force is approach to calculate the power of 3 modulo 353, stopping where the result equals either 40 or 258, and desired answer reached with the exponent value of 97, which provide 3 to the power 97 or 353 is equals to 40, and the brute force algorithm works to break this algorithm. And with a larger number, the problem become impractical. That's why we are always saying that take two large prime numbers. As if we are taking the large prime number, large numbers, it is very tough to identify by using any algorithm. Okay. So one more thing is that how the Diffie-Hellman algorithm is not worked perfectly, because there is a limitation in Diffie-Hellman. The one limitation is already we have discussed. If everyone know the numbers, what the party A and party B has, then there is a problem issue. Another is man-in-middle attack. Suppose, for example, I am saying that Darth generating two private key, XD1 and XD2, and then computing the corresponding private key, both computing the different private key. Alice transmit YA to Bob, and Darth intercept YA and transmit YD1 to Bob. Darth also calculate K2. Bob receives a value from Alice and calculate another, and Bob transmit the YB to Alice. Now what is the problem? The problem is this is the limitation that if both party identify the same number, then Bob and Alice think they can share a secret key. Both can share a secret key rather than calculating this is. Then the situation is different. Because if we are doing this thing and again we have to identify this 3. So this is very tough situation, because a new number is the same and we can share this number. So in the previous, if we are assuming that a common number can be shared between us, then it is a problem. So man-in-middle attack is what? The symmetric key shared key is the Diffie-Hellman protocol is K is equals to G to the power XY mod P. So everyone can identify the key generated by either by the Bob or Alice or both of the party. So this is a man-in-middle attack. It works. Let's see. The two parties are working, the party 1 and party 2. It is transmitting some information, it is also transmitting some information. Another person here, an attacker, is there. The attacker is a passive attacker, not the active attacker. Difference between active attacker and passive attacker can read the values transmitted by any party, and active attacker is those who can change the values transmitted by any of the party. So the passive attacker can read what you want to share. If I am reading, I am analyzing what you want to share, I am checking everything. then obviously I have every information that if you want to keep it secret, I know that. So this is a problem in Diffie-Hellman algorithm, and Mad-Hellman attack is the problem where we have to find the solution of this man-in-middle attack. So let us give a trivial example to make it a procedure clear. The example uses very smaller number, but not in that real situation. The number are very large. Assuming the G is 7 and P is 23, the steps are this. Alice choose 3, Bob choose 6 and calculate this one 21 and 4. Alice 21 and 4 both are exchanging. Alice calculates symmetry key 18 and 48. Now the value of K can be calculated also, which is 18. The value of K is the same for both Alice and Bob. The G to the power xy mod P is equal to 7 to the power 18 mod 23, that is 18. Same for both. So this is attack. Now let's see what is man-in-middle attack. R1 generated by the Alice and there is a Bob. This is the Eve which accept the R1 and generate a R2. This person came in existence before R1 delivered to Bob. R1 is not delivered to Bob. One person came in existence and received the R1 and generated a value and sent to Alice. And also this R2 sends to Bob also. So my random number means what? This random number, the Bob did not receive the random number generated by the Alice, and Alice did not receive the random number generated by the Bob. They both are receiving another number generated by this passive intruder. This passive intruder. इसने क्या दोनों को अपनी अपनी keys भेज. Now what is the problem? This is a man-in-middle attack. It came into the existence between two parties. Whatever you are sending, it comes to me. I am generating a number and send it to you also, and this number send it to you also. Whatever you are generating, you send it to me also, and I send it to you also. So I am the middle person, and who can every communication between your side. Okay. So this K1 and K2, and Alice Eve key, Bob Eve key, K2 and K1. If I am checking the key, different, because R2 is shared with this one while Alice shared R1, but Bob received R2. In the similar way, Bob shared R3. So what is the situation is here? What is the problem is here? That a person came in existence and generated two number generated by the same formula, but shared with this one, and both parties do not know the man-in-middle attack. They are sharing the information with Eve. The Bob do not know that Alice want to communicate. Alice want to communicate with Bob, but Eve came in existence and read the value of R1 and generated R2 and gives to Alice, and read every communication between the Alice. In the similar way, the Eve generated a random number and gives to Bob, and Bob gives the R3 to Eve, and they are communicating with each other. So Eve is reading the every personal information from Alice and every personal information from Bob. So this is the man-in-middle attack. Here in this case, the K1 and K2 are different, because this K1 key is K1 is equal to G to the power xy mod P, and this is G to the zy mod P. So this is the difference. So the key is different in this case. So this is a man-in-middle attack. So to avoid this man-in-middle attack, what we have to do? There is when we study transport layer, there are some sequence number and acknowledgement numbers also, but there is a problem again in that also. So what we have to do? We have to use a three-way handshaking method. If we are using three-way handshaking method, then we must ensure that the another party is actually your receiver or not, because there is no method that the key exchanging is sufficient for us. The method is to identify the yours identity in another way. What another way? If you are the actual user, then you need to share your MAC address, your IP address to me, so that I can find that you are the actual user or not. So these type of things, authentication protocol can be used to avoid this man-in-middle attack. If there is any secret key transmitted or information is transmitted to you, the authentication protocol must be in use to identify that you are the actual user, and whatever you are producing is given by the actual user only. Let's say, for example, if this R1, R2 generated by the Eve, it must know that R2 generated by the actual user or not. It automatically detects that R2 is the generated by some attackers. It automatically know. Today's, if we are not using this particular Diffie Hellman in RSA algorithm, this problem is solved, because there is no problem in middle attack. But this is the situation. This is the situation where P and G are the public. In RSA, it is not public. The two random numbers are there in RSA also. Two large prime numbers are there, but they are not public. Public nahi hai. This is the main beauty of RSA. But we cannot say that this algorithm do not give any idea behind public key and private key. This algorithm is very important, that if we are encrypting a message using the same key and you are decrypting the message using the same key, this algorithm gives a new idea that I am encrypting the message using my key and you are decrypting the message your key. So there are two keys, encryption and decryption, both are done by the different keys. So this idea given by this algorithm, and this algorithm later on is converted into RSA. RSA reversed, Shamir and Edelman gives the better algorithm. Okay. So if we check that this, what is the problem there? The one problem is that P and G, two random number 13 and P, both number are shared, 13 and 6. This is the main problem. Another thing is that exchanging public key exchange, and then after that a shared public key is generated. Shared public key, it is also shared. If I am sharing this 13 and 6 and again identifying or shared public key, this is a problem. Why we are exchanging in each and everything? So man-in-middle attack is very common approach to detect or to identify or to break this type of algorithm. So we should avoid any type of this type of thing, because nowadays cyber security plays a very vital role. The security, everyone wants to share, want to keep their message private. For privacy, there are different options are there. Nowadays you see that if you are using mobile phone, so by opening a mobile phone, there is a password. If you want to call a person, there is a password. If you want to open a WhatsApp, there is a password. There are multiple passwords are there. You are keeping your information safe and private. Then in this information, we are saying that this numbers is shared between us, and again the key is generated is the same. So this is a problem. So that's why using safe and secure algorithm, another algorithm came in existence. DES, triple DES, RSA and AES algorithm are the most appropriate algorithm. Currently we are using that algorithm. Okay. So if you want to study more about these algorithms, you can refer the fourth cryptographic, frozen cryptographic book. So this is the book name. Okay. Frozen Cryptographic and Network Security, where we can see that different types of protocol like SHA, because currently we are using, like for example, hash function, hash keys. What is hash key? This is basically advanced algorithm. Nowadays that you are saying that by using by zipping a file, if you are compressing a file, there are two keys needed. To open a file, there are two keys needed. Like for example, in your ATM card also. When you are inserting your ATM card, it automatically read that what's your name. Read by their chip, by their inserting the ATM card, it read the basic information about yourself. I am saying that how the machine knows my name. It know the machine know the your name by using the reading the card number. The card number is public, but what is private? Private is what? The key, the password. The 4-digit key is the password. You say that the 4-digit key is very common. If we are applying brute force algorithm, everyone can read the 4-digit combinations very easily. But there is another thing is that the machine detect 3 false attempt, it automatically block the card. Block the card for 24 hours. In next 24 hours, it again unblock and then again try next 3 password. So this is the just stopping. If you are using brute force, it automatically check that you can attempt the fake password or the try and try. So it will give you only 3 or 4 attempts only. So after 24 hours, you will be able to use again. It's a longer time. And message came to me that someone wants to use your credit card or debit card by using some fake keys. The message came to you. Another thing is that some person issue a duplicate credit card also or debit card also. Some person taken the random taken your mobile number also. So it also show that it shared some information of your side. So just avoid to share the information. Okay, thank you.